The Zenmuse P1 is DJI-first aerial surveying camera equipped with a full-frame sensor on a 3-axis stabilized gimbal. What's special about this payload camera is that it's designed for aerial surveying. Before elaborating on the P1, let's take a look at the aerial surveying process. First, set a flat rod, then take off and capture images. And finally, import images into reconstruction software to create a 3D model of the area. We can use this model to measure location, coordinates, distance, area, and volumes of an object. Aerial surveying helps us to obtain geographic and spatial information, which allows us to create digital copies of our world. A good camera is essential in this process. The P1 outshines its predecessors with its full-frame sensor. The size of full-frame sensor is 36mm x 24mm. The area is 7 times that of the sensor on the Phantom 4 RTK. That's great, but how can aerial surveying operations benefit from the larger sensor and pixel size? The P1 delivers an effective resolution of 45 megapixels, which captures an area that's 2.25 times image size of the Phantom 4 RTK, which has a 20 megapixel sensor, effectively extending both the length and the width of the image by 1.5 times, giving you the same ground image resolution while requiring a shorter flight rod. In addition, the shortest photo interval of the P1 is 0.7 seconds. When mounted on the M300 RTK drone platform, the P1 can fly at up to 15 meters per second for a 1:500 scale mission. If we want to collect the data to create an Austral mosaic for an area of 10 square kilometers or just shy of 4 square miles, only 4 flights with the P1 are needed. These specs look great on paper, but do they actually improve the fieldwork efficiency? To find out, we pitted the P1 and M300 RTK against the Phantom 4 RTK. Given the same GSD, we flew the Phantom 4 RTK and the P1 for a 15-minute operation under the recommended operating parameters, and compare the areas covered by each of the 2 cameras. The results indicate the area covered by the P1 is 4.3 times that of the Phantom 4 RTK. Aerial surveying operations are often at the mercy of weather conditions. Environments with snow or not enough light would make it impossible for many aerial surveying cameras or drones to work properly. Let's see if the P1 can stand the test of night loop and render usable data. Aerial surveying at night is difficult for cameras and platforms by every stretch. Let's take a look at the performance of the P1 and M300. It's 9 p.m. right now and completely dark outside. I'm flying both the Phantom 4 RTK and the P1 plus M300 RTK to reconstruct the building in front of me. Here are the results. The model using images from the P1 is on the left, and the one made with images from the P4 RTK is on the right. They're visibly different, aren't they? Why the difference, you might think? The P1 benefits from the pixel size or the photosensitivity area of single pixels of 4.4 μm, which is 1.8 times that of the Phantom 4 RTK. The larger pixel size means a larger pixel well that can accommodate more photos, achieving a higher signal-to-noise ratio and exposure latitude. This greatly improves the image quality of the camera under low light conditions. Aerial surveying is often carried out at noon when there is sufficient sunlight. A higher light ratio poses a major challenge to the camera's latitude. When there is not enough latitude, you lose details in underexposed and overexposed area of an image. For example, this control point photo is taken by the Phantom 4 RTK camera at noon. Due to having a lower latitude, the text on the marking is overexposed and you can't fix it in post-processing. In contrast, the photo taken by the P1 camera retains most of the details. There is no blooming, and you can still see the details in the darker areas. During the subsequent aerial triangulation, there will be more matching images. For example, here we see the same road in the example dataset. The images from the P1 contain more feature points when you stitching them together. This means it's easier to match the photos. We have optimized the P1 for aerial surveying operations. The aerial surveying cameras we have seen were mostly modified version of a consumer-grade digital camera. When used in dark environment on auto exposure, the shutter speed would decrease fast, resulting in blurred photos. The P1 is optimized to have a shutter priority to avoid inaccurate data due to motion blur. The sharpness of image is also optimized, so the edges are going to be very clear, while the accuracy is improved. To get the best image quality, a good lens is just as important as the sensor. Most full-frame camera lenses have a big old metal body, but not the P1 carbon fiber lenses. They are integrated, lightweight, and compact, and come in the 24mm, 35mm, and 50mm focal lenses. The most commonly used 35mm lenses assembly has 9 lenses, which include 3 aspheric lenses, which greatly reduce distortion and ensures that you can capture accurate data for photogrammetry. What is the resolution of the DL lenses? In short, it's capable of capturing 8K images. Let's look at the MTF curve of the DL lenses. This curve represents the image quality and ability of the lenses in shooting samples in different positions. Take the 35mm lenses, for example. At 10 lines per millimeter, at the center of the frame, we can see that the MTF value is above 0.95, and at the edge area of the frame, the image quality does not appear to be greatly attenuated. The MTF value is above 0.9. As you can see, the DL lenses are uniquely fit for aerial surveying. They are lightweight and plug and play, and can obtain images that are clear, sharp, and less distorted. Now that we have covered resolution, let's look at the jelly effect, which is related to the shape of the shutter. The jelly effect will result in compressed or enlarged image during the high-speed flight. The P1 uses the central lift shutter that's between lenses, which minimizes the jelly effect. What's more, combined with the pixel-level image stabilization provided by the high-accuracy 3-axis stabilized gimbal, the jitter within the exposure time can be kept within 1 pixel during high-speed flight. Ensure a clear image, the P1 also supports a wide range of aerial surveying functions during operations, such as autofocus, temperature compensation, and infinity focus in one tap. To create an accurate model, just a good camera isn't enough. We also need accurate location information. Aerial surveyors used to have to walk long distance to place a lot of GCP, which would be quite a heavy workload and poses many safety risks. With solutions like the P1, we want to introduce to you accessible aerial surveying technology that requires no GCPs. The M300 RTK is equipped with 2 RTK modules, which can provide centimeter-level positioning information and supports NetRTK, DRTK 2.0 high-precision GNSS mobile stations. A GCP-free surveying operation is truly made possible. There are RTK drones on the market, but few can go without GCP. This is because the positioning data obtained by the RTK system is the position of the antenna itself. But we need the position information of the actual photo. For this reason, the M300 RTK is equipped with position synchronization system called TomSync 2.0. It was created to continually align the flight controller, camera, and RTK module. Additionally, TomSync ensures each photo uses the most accurate metadata and fixes the positioning data to the optical center of the lens. optimizing the results from photogrammetric methods and letting the image achieve centimeter level positioning data. This way, the photo can also have an accuracy at the centimeter level. Test results indicate that in a 1 to 500 arrow surveying operation without GCP, the drone can achieve an horizontal accuracy of 3 cm and a vertical accuracy of 5 cm, both meeting the requirements of arrow surveying without GCPs. To truly deliver data without GCPs, having RTK without syncing position information is not the way to go. People literally employ multi-rotor drones to collect 3D image data of small area because of the sheer amount of image data needed for the reconstruction. A single camera drone would need to fly 5 routes to cover all the directions. To elevate efficiency, DJI engineers developed the Smart Oblique Capture function used on the M300 RTK. The P1 can continuously capture oblique images from 5 directions along the flight route. This can raise its coverage area to 7.5 square kilometers per day. In addition, the P1 intelligently captures only the photo essential for reconstruction at the edges of the survey area, which can reduce the number of the photos taken and improve the post-processing efficiency by 20 to 50%. What does this mean in the field? Assuming that the GSD is the same and the same survey area is dropped. The Phantom 4 RTK used 5 flight routes, whereas the P1 will be using the Smart Oblique Capture function. Let's compare the time and the number of photos taken, although their resolutions are different. In the test, the P1 finished the job in just 1 flight, while the P4 RTK needed 2 flights. Let's check the final results. The P1 was in action for 5 minutes and 34 seconds, while the Phantom 4 RTK took 26 minutes and 15 seconds. We can see that the P1 is 4.7 times faster than Phantom 4 RTK. And the P1 took just 97 photos compared to 472 by the Phantom 4 RTK. Overall, the P1 reduced the number of photo pixels by 53%. The following data is summarized from several tests. Back when we first started doing aerial surveying, we need at least 3 people, a vehicle, and large ground station. We also needed to score the takeoff and landing sites and set up GCPs in really hard to access places. After the drone took off, you could only see the basic flight parameters. There was no real-time video transmission, and we'd often lose the drone. Every time the connection dropped, my boss would start to pray that we don't go home with just RC and not the drone. After a busy day in the field, I would often have to sort out the post data and thousands of photos at night, one single mismatch, and I had to go over everything all over again. Now I can just roll out a drone in suitcase, grab a remote controller, and I'm all set for my surveying mission all by myself. I can monitor the drone in real time through transmitted images and flexibly control the camera based on the actual situation on site. During the operation, the drone can automatically avoid obstacles and intelligently return to home. In addition, the IP45 rating of the M300 RTK in particular gives me more peace of mind when the operating conditions are less than ideal. These advanced technologies have significantly changed our lives. Now we can do the work much safer, quicker, and easier.